Today, we are going to discuss about tectonic plates and its effect. We have all heard about the recent devastating earthquake of Turkey and Syria. We are also going to discuss how the Himalaya was created and how it changed the climate and, also how volcanic eruption happens because of plate tectonic. We will also discuss how Africa will split in the East African Rift Valley. But, first, we are going to discuss about the evolution of tectonic theories. Early tectonic plate theories. The similarities in shape of the Atlantic coastlines of South America and Africa were noticed by Francis Bacon in 1620. It is one of the earliest known hypotheses of plate tectonic. In 1908, F. B. Taylor propounded the continental drift hypothesis, incorporating many other geological evidences. Continental drift theory was proposed by Alfred Wegener in 1912. According to Wegener's continental drift theory, all the continents were one single continental mass, called a supercontinent. Pangaea and a mega-ocean surrounded this supercontinent. The mega-ocean is known by the name Panthalassa. According to this theory, the supercontinent, Pangaea, began to split some 200 million years back. Pangaea first split into two big continental masses known as Gondwanaland and Laurasia, forming the southern and northern modules respectively. Later, Gondwanaland and Laurasia continued to break into several smaller continents that exist today. There are many evidences supporting the continental drift theory. The matching of continents, jigsaw fit. The geographical similarity between the opposite coasts of the Atlantic Ocean. The outlines of the two coasts appear to be the detached portion of the other, i.e., the east coast of North and South American can be exactly fit into the left coast of Africa and Europe. Distribution of fossils. When identical species of plants and animals adapted to living on land or in fresh water are found on either side of the marine barriers, a problem arises regarding accounting for such distribution. Wegener proposed that the organisms had lived side by side, but that the lands had moved apart after they were dead and fossilized. In 1967, Mackenzie, Parker and Morgan gave the concept of plate tectonic. Theory of plate tectonic states that the Earth's outer crust, i.e. lithosphere, is divided into plates, 7 major and 20 minors, that move over the asthenosphere, the molten upper portion of the mantle. Plate tectonics is responsible for various geomorphological processes such as folding, faulting, etc. The theory of plate tectonics provides the necessary rationale for the distribution of oceans and continents around the globe. A tectonic plate, also known as a lithospheric plate, is a massive, irregularly shaped slab of solid rock made up of both continental and oceanic lithosphere. Plates range in size from a few hundred to thousands of kilometers across. The Pacific and Antarctic plates are among the largest. Plate thickness varies greatly as well, ranging from less than 15 kilometers for young oceanic lithosphere to 200 kilometers or more for ancient continental lithosphere, for example, the interior parts of North and South America. The continental crust is made up of granitic rocks, which are composed of relatively lightweight minerals like quartz and feldspar. The oceanic crust, on the other hand, is made up of basaltic rocks, which are much denser and heavier. The 7 major plates are, North American plate, South American plate, Pacific plate which is the largest plate, Antarctica and the surrounding oceanic plate, Eurasia and the adjacent oceanic plate, Africa with the eastern Atlantic floor plate, India, Australia, New Zealand plate. The reason of plate movement. Although this has yet to be proven with certainty, most geologists and geophysicists agree that plate movement is caused by the convection, that is, heat transfer resulting from the movement of a heated fluid, of magma in Earth's interior. The heat source is thought to be the decay of radioactive elements. How this convection propels the plates is poorly understood. Some geologists argue that upwelling magma at spreading centers pushes the plates, whereas others argue that the weight of a portion of a subducting plate, one that is forced beneath another, may pull the rest of the plate along. There are 3 types of plate tectonic movements. Divergent plate boundaries, convergent plate boundaries, transform plate boundaries. Divergent plate boundaries. Those plates that move away from each other consistently are called divergent plate boundaries. This type of interaction results in the formation of mid-ocean ridges, such as the Mid-Atlantic Ridge. The basaltic magma erupts and separates here, seafloor spreading. Divergent edges are places where the Earth crust is formed, hence the name constructive edge, and volcanic earth formations are common along them. Along diverging margins, earthquakes, with a shallow focal, are prevalent. There are three types of divergence. Continent-continent divergence or CC. Ocean-continent divergence or OC. Ocean-ocean divergence or OO. Continent-continent divergence or CC. The African Rift Valley is an example of a CC divergence. In this type of movement, in the first phase crack happens in the boundaries line. In the second phase, the valley is created. In the later phase, the ocean is created. The East African Rift Valley, produced by the divergence of the African and Somali plates, is the most important geomorphological feature on the continent. After million years new ocean will form between African and Somali plate. Continent-ocean divergence or CO, expansion of the ocean can happen in this case. Ocean-ocean divergence or OO. The Atlantic mid-ocean ridge is an example of the OO divergence. Convergent plate boundaries. When continental and oceanic plates collide, the oceanic plate, which is thinner and denser, is pushed aside by the continental plate, which is thicker and less dense. In a process known as subduction, the oceanic plate is driven down into the mantle. The oceanic plate is thrust into higher temperature environments as it lowers. Materials in the subducting plate begin to approach their melting temperatures at a depth of about 100 miles, 160 kilometers, and partial melting begins. There are again three types of convergence. Continent-continent convergence or CC. Ocean-continent convergence or OC. Ocean-ocean convergence or OO. Continent-continent convergence or CC. The convergence of the Indian plate and the Eurasian plate is an example of CC convergence. In this type of interaction, heavier continents plates will be submerged. Since the continent plates are high in thickness, hence volcanic activities can be rarely seen, however, at the boundary line. Earthquake, fold mountains, and landslides phenomenons are common. The most active example of continental convergent plate boundaries is the Himalayan mountain range. Around 55 million years ago, India and Asia collided, forming the Himalayas, the world's largest mountain range. The Indian and Eurasian plates are colliding right now. The creation of Himalaya. From about 50 to 40 million years ago, the rate of northward drift of the Indian continental plate slowed down. This slowdown is interpreted to mark the beginning of the collision between the Eurasian and Indian continental plates, the closing of the former Tethys Ocean, and the initiation of Himalayan uplift. The Eurasian plate was partly crumpled and buckled up above the Indian plate, but due to their low density/high buoyancy neither continental plate could be subducted. This caused the continental crust to thicken due to folding and faulting by compressional forces pushing up the Himalaya and the Tibetan Plateau. The thickening of the continental crust marked the end of volcanic activity in the region, as any magma moving upwards would solidify before it could reach the surface. The Himalayas are still rising by more than 1 centimeter per year as India continues to move northwards into Asia, which explains the occurrence of shallow focus earthquakes in the region today. The creation of Himalaya changed the climate of the planet. It is believed that the uplift of the Himalayan plateau is thought to have been instrumental in bringing on the ice ages because all silicate weathering reduces CO2 in the atmosphere and hence cools the planet. So the uplift created more silicate weathering, which lowered the greenhouse effect and hence, glaciation. The recent earthquake in Turkey and Syria happened because of the continent-continent convergence. Continent-ocean convergence or CO. The conversion of the Pacific Ocean plate and American plate is an example of the CO boundary. Generally, ocean plates are heavier than continental plates. Submergence of ocean plates happens in this case. At the boundary line, trench, volcanic mountain, fold mountain, earthquakes, and landslides are common phenomena. The Andes and Rockies are formed by convergence of the Pacific Plate with the South American and North American plates respectively. Ocean convergence or OO. In this case, two ocean plates converge and one of the heavy ocean plates submerges under the others. Volcanic activities and earthquakes are the common phenomena of this convergence. The Ring of Fire in the Pacific Ocean is an example of the OO convergence. Transform plate boundaries. Two plates slide past each other in this type of interaction, and no new landforms are created or destroyed, only the present landform is deformed. Transform faults are planes of separation in the oceans that are often perpendicular to the mid-oceanic ridges. The best example of a transcurrent edge on continents is the San Andreas Fault. Silicon Valley sits dangerously close to the fault line, on the western coast of the United States. These boundaries are conservative because plate interaction occurs without creating or destroying crust. Hence, they don't produce spectacular features like mountains or oceans. In these areas of contact, stress is built which causes the rocks to break or slip, suddenly lurching the plates forward and causing earthquakes. These areas of breakage or slippage are called faults. The majority of Earth's faults can be found along transform boundaries in the Ring of Fire. The San Andreas Fault in California is an example of a transform boundary, where the Pacific Plate moves northward past the North American Plate. The 2015 movie San Andreas starring Rock the Dowan Johnson has shown the disaster that could occur because of this fault line. It is one of the most active faults on the Ring of Fire. Thank you for watching this video. If you enjoyed the video, please do consider to hit the like button, also share the video and do consider subscribing to the channel.